Limited proportional region is not useful in clinic. But if we keep increasing the voltage, we will enter a clinically useful region, which is called Geiger Mueller region, right here. So what happens in the Geiger Mueller region is as the voltage keeps increasing, there are more and more ionized electrons. Some of them form an electron cloud. For example, these are the negatively charged electron clouds here. These electron clouds, because they are in negative potential, they will repulse other ionized electrons. For example, they will repulse the electrons over here. This repulse effect is called space charging effect. Basically, it shields other ionized electrons. That is why the signal in the GM region is relatively flat. There is one unique, notable feature of the GM region, which is the output signal is not related to the intensity of the incoming beam. This means as long as there is an incoming beam, no matter it is low or high intensity, the detected signal in the region, in the GM region, it's always the same, and more importantly, quite high, right here. This makes the GM region very useful for clinical use. For example, for finding a lost seed in prostate seed implant procedure. And by the way, a detector running at GM region, which is normally called a GM counter, is used for this purpose. So in prostate seed implant procedure, we use very low energy radioactive sources to implant in the prostate to deliver radiation. Because the seed energies are in the range of 20 to 30 keV, their incoming intensities are quite low. However, a GM counter will pick up these low energy signal and detect an equally high output signal, for example, in here. So if there is a lost seed accidentally fall on the floor and we want to find exactly where it is, we will use the GM counter to scan the floor, and when it is near the lost seed, the GM counter will pick up a quite high signal, so we will easily know where exactly the seed is. And notably, the flat signal in the GM region means a GM counter cannot distinguish what types of incoming beam is. For example, in here, all three kinds of beam, alpha, beta, gamma, they behave differently from the region number 1 to number 4, but they kind of converge to a flat signal in the GM region. And they produce, as long as any of them coming in, they produce the same signal in the GM region. So lastly, if the voltage gets even higher, the ionized electrons become more energetic. So spontaneous or continuous electric discharge begins to happen, which is what happened in the region 6. So basically, the output signal cannot be related to any useful information of the incoming radiation beam. The ionization chamber begins to malfunction, and this region is called continuous discharge region, and this region is not useful for any detection.